Okay, this week our topic is volcanoes. You can see a lovely picture of a volcano in the background right there, and an area in the foreground that's been impacted by that volcano. Our questions for the week, as with every week, um, would you live near a volcano? Now, the sub-question this time is, if so, which type? We'll see that different types of volcanoes have different styles of eruption. So that's going to be a very important aspect that you'll want to consider when you're looking at whether or not you would live near a volcano. What level of risk from volcanoes is acceptable to you? And that, again, is linked to the type of volcano. How would you know if the volcano risk was assessed accurately? And when you read through the book, one of the things that you'll see again is the different types of volcanoes, and they look different, they have different characteristics. So that would certainly be part of the risk assessment. And then finally, what should be done by people and communities near a volcano to prepare for the hazard and prevent catastrophe? As I said, the different styles of volcanic eruptions and the different types of volcanoes are linked together, and those are going to be really important. So we'll want to talk a little bit about what causes the eruptions to vary and why you have different types of volcanoes and different styles of eruptions. So let's begin with a discussion of igneous composition. And igneous rocks are rocks that form from the solidification of molten rock. So these are the types of rocks that form during volcanic eruptions, because molten rock comes out of volcanoes. So there are three basic types of igneous composition. There are felsic rocks. The volcanic rock associated with felsic rocks are called rhyolite and granite. The picture up at the top shows you some felsic rock. You'll notice it's pink. Mafic rocks, which are down at the bottom, are black, although they look kind of brownish in this slide. And then the intermediate rocks are a mixture of black and white, so they're in between. So when we go to the next slide, and this table is from your book, this shows you the rock type formed: basalt, rhyolite, andesite, and the different eruption types. So let's go ahead and start under the rock type formed. Basaltic type igneous rock, generally speaking, has a low viscosity. So as you read off to the left there from rock type formed, you'll see low viscosity and low silica content. This makes for a lava that flows very fluidly. So that low viscosity means it flows very smoothly. Because of that, when you have an eruption, you get a lot of lava flows. Sometimes, if there's a fair amount of gas, it'll throw that lava in the air, and it will give you what we call tephra, which are little pieces. And they'll build up like a little spatter cone. But generally speaking, this volcano is going to be built from a fluid, and so it's going to be broad and flat. And so you'll notice where it says shape, it says gentle arch, shield shape. And this is what we call a shield volcano. If we have what we would call an intermediate type volcano, andesite, you'll notice it says composition, basalt, andesite, rhyolite. These volcanoes have basalt, but they also have andesite and rhyolite, which are stickier lavas. So essentially what happens is, during an eruption cycle, you'll get a different type of molten rock coming out. If it's basalt, you get that nice smooth lava flow. If it's andesite or rhyolite, it's a much stickier lava, and it will tend to dome up, and it will also tend to explode. That sticky lava kind of holds in the pressure, and so when the eruption comes, it's explosive and throws things in the air. This will give you a more cone-shaped, steep-sided volcano. But because you have the basalt type eruptions occurring every now and then, that will cover the ash and protect it and preserve that steep-sided volcano. This can make really tall steep-sided volcanoes. And this really is the classic type of volcano that most people think of when they think of a volcano. They're usually thinking of a composite type volcano. And we'll see some pictures of these on the next slide. The other two types of volcanoes listed here, the volcanic dome is what you find when you have this really sticky rhyolitic lava. And what happens is it's so sticky it kind of pushes up out of the ground and makes a giant lava bubble that's solid on the outside, and it just gets bigger and bigger and kind of domes up. These are very, very explosive. Sometimes you will find one of these domes growing in the top of a composite volcano. So you'll notice the composite volcano kind of shifts back and forth. When it has a more rhyolitic type lava coming out, it'll grow a dome in the crater of the volcano. And then down at the bottom it mentions cinder cones. To make a cinder cone you have to have a very explosive eruption. And generally speaking what happens is you have a basaltic type lava, but you have a lot of gas to throw that lava in the air. And so it builds up this cone with very steep sides, generally not very big, because these tephra deposits are not very durable. So these tend to be young, they don't last very long, they'll wash away. Now geologically speaking, I mean last very long. So in human terms it's a permanent structure. In people terms it's around for a long time. In geologic terms these are not around for a very long time. One of the volcanoes they list here on the chart, Paracutine, is the only volcano that we've seen grow up from nothing. So the only volcano we've actually seen grow up out of bare earth was Paracutine, and it started in the, I believe it was the 1940s. It started to erupt and grew up into like a 1,000-foot high cinder cone. It's pretty cool. So let's talk a little bit about risk and go through the rest now that you understand the composition, because this is really key to understanding the volcanoes. So the volcanic cones, the composite cone is shown on the upper right. That is your classic volcano looking volcano. The cinder cone is in the lower left. That looks volcanoish as well. On the lower right is the shield volcano, and you might not recognize that as a volcano, but it's made mostly of lava flows, and these can be kind of dangerous to live near just because the lava can flow a great distance. So what kind of hazards do we see? Well, we get pyroclastic material. So if the volcano has a kind of an explosive eruption, what we might see is a lot of ash falling down, and you can see that that can bury things. It can set them on fire because the ash is quite hot. And in the lower left you can see a picture of casts that were made of people that were buried in ash falls in Pompeii. So that's kind of a pretty famous eruption. Those folks were suffocated by the ash, and after they died they were then buried in the ash, and the shapes of their bodies were preserved. And there's a picture of an ash eruption in the lower right. Lava flows, of course, are a hazard. Lava flows don't move very quickly, so generally speaking you can walk away from them. However, if your house is in the way, as you can see in the upper right, it will get burned down. So it's not a risk to be taken lightly, but it is something that tends not to kill a lot of people simply because people can move out of the way. But it can cause enormous damage to structures. There are two types of lava flows. You can see in the upper right that kind of lava flow that's spreading out and kind of flat is called a pahoehoe lava flow. The one in the lower right you'll notice is kind of blocky. It kind of tumbles over itself. It moves a little bit more slowly, and that's called an lava flow. In the lower left you can see a lava flow threatening a town. You'll notice there's a lot of steam rising up off of the lava flow, and that's because the folks in the town are spraying the lava with water in order to slow it down or perhaps stop it. And so that's one of the things to think about is there a way to redirect these hazards? Volcanoes are pretty hard to redirect the hazards, but sometimes lava flows can be diverted. And you can read in your book to find out some other ways that can happen. Some other hazards we see with volcanoes, poison gases actually turns out to be kind of unusual because the gas has to be trapped in a confined area to build up into a large enough concentration. There are some special cases discussed in your books, and so poison gases are a hazard around some volcanoes. On the lower right, you see a lahar, which is a hot mud flow. If you think back to this previous picture here, if you look at the volcano in the upper right, you'll notice it has a lot of snow on top. So when the volcano erupts and that snow melts, it can mix with the ash and create a hot mud flow. And these lahars can travel many miles from the volcano. On the lower left is what we call a pyroclastic flow, and this is when the hot ash is supported by hot gas. And pyroclastic flows are probably the fastest moving of the volcanic hazards. They can go 60 to 70 miles an hour, and they're extremely dangerous. That's probably what buried the people in Pompeii. There's a special type of eruption called a caldera-forming eruption. This is kind of the mega eruption, where the volcano loses. If you look on the right-hand side, you can see a series of figures. The volcano empties part of its magma chamber, collapses into it, and very often this results in a secondary explosion as that material, the cold material, hits the hot material down in the magma chamber and pretty much blows the top off of the volcano. So those are super dangerous, not very common, but maybe one a century blows up, or every couple hundred years. The last one that happened was the island of Krakatoa, and when it collapsed, seawater rushed in, hit the hot lava in the magma chamber, and created a very large secondary explosion that was heard 3,000 miles away, created an enormous tsunami. The picture on the lower left here is from Crater Lake in Oregon, which erupted a couple thousand years ago. What causes volcanoes? So how do we assess this hazard? Well, volcanoes are related to plate tectonics. Your book has a nice discussion of the different types of plate boundaries where we find volcanoes. And what you'll notice on this diagram is that different types of volcanoes are associated with different plate tectonic features. So where two plates pull apart, we tend to get shield type volcanoes. Where plates converge and one subducts, that's shown there with the chain of composite volcanoes on the left and the right of the little ocean basin. And so the type of volcano is actually related to the type of plate boundary, and of course the type of eruption you get is related to the type of volcano. So that's something to keep an eye on in the book, and that's really a big part of how we assess the danger of these volcanoes. So our risk zones, you can see, are the big risk zone is called the Ring of Fire. It's around the Pacific Ocean. The Pacific Plate is going underneath the Eurasian Plate, the North American Plate, South American Plate, Australian Plate, and so it makes these explosive composite type volcanoes. If we want to try to set up some risk zones, we essentially look at what type of volcano it is, and we can map out the different types of hazards associated with that type of volcano. How do we know when a volcano is going to erupt? Well, when molten rock comes into the volcano, it's probably getting ready to erupt. And so by monitoring seismicity, gases coming out of the volcano, and the shape of the volcano, we can do a pretty good job forecasting the eruption.